Hi, welcome to my channel. This is Kauserwise and this is the continuation video of crashing the network. In the previous video, we have seen the first part in the second model, that is crashing the network with single critical path along with the total float calculation. Okay, now in this video, we are going to see how to crash the activity systematically and determine the optimum project time and cost. Okay, let us see the solution. Now we'll move on to crashing the network. Okay, for that we have to follow few important steps. The first step is calculation of crash limit and slope. Okay, so here we have activity which is given in the problem. Next we are going to calculate crash limit and slope. For crash limit, see the problem. Here we have normal duration and crash duration. The difference between these two is called crash limit. Okay, for the first one, 6 minus 4, 2. Then 5 minus 4, 1. 6 minus 3, 3. 7 minus 4, 3. 10 minus 8, 2. 5 minus 4, 1. 4 minus 3, 1. This is crash limit. See the calculation. We have entered crash limit. Okay. The next calculation is slope. We need to find out slope for each and every activity. For that, we need to apply one simple formula. See the formula. See, this is the formula to find out slope. The formula is crash cost minus normal cost. Okay, so this is given in the problem. Okay, so crash cost is given separately for each and every activity, as well as normal cost also given for each and every activity. Okay, for each and every activity, just find out the difference between crash cost and normal cost. Enter the value divided by normal time minus crash time. So crash and normal duration also given in the problem for each and every activity. So this is the crash time and this is the normal time. Just find out the difference. Okay, enter here. Then you will be getting slope for each and every activity. See the calculation. See, we have calculated the slope value by using the formula. Okay, for activity 1 to 2, 75, 2 to 3, 50, 2 to 5, 150, 2 to 4, 120, 3 to 5, 25, 5 to 6, 110, 4 to 6, 160. Okay. See, the next step is we are going to crash the network with the help of this data. Okay. Now, look at the network diagram which we have drawn in the previous video. That is part 1. Here, three possibilities are there from starting node to ending node. Okay. See the first possibility. 1 to 2, 2 to 3, 3 to 5 and 5 to 6. What is the duration? 6 plus 5 plus 10 plus 5. 26 days. Okay, this is the project completion time. And the second possibility is 1 to 2, 1 to 2, 2 to 5 and 5 to 6. The duration is 6 plus 6, 12, 12 plus 5, 17. 17 days. The third possibility is 1 to 2, 2 to 4 and 4 to 6. Duration is 6 plus 7 plus 4. So total 17 days. Okay. So out of these three possibilities, which one is longest path? The highest duration is 26 days. Okay. So this is the first option is the critical path. Okay. So critical path means longest path which required highest number of days to complete the project. Okay. See the problem. We have done the first part. That is, we have drawn the network and identified the critical path. What is the second one? What is a normal project duration and associated cost? Now let's see the calculation. See the solution. The next one is normal project duration. Okay. So what is the critical path duration? 26 days. No. So that is the normal project completion time. 26 days. And the second one is associated cost for the normal project completion time. So total cost is equal to direct normal cost plus indirect cost. Okay, for that, see the problem. Here they have given normal cost for each and every activities. Okay, see what is the total cost? Normal cost amount 6,000. Okay, this is the normal direct cost. And the second one is indirect cost also given in the problem. How much? The indirect cost of the project is 100 rupees per day. How many days is required to complete the project? Normally 26 days, no. So 100 into 26, 2600 is the indirect cost. Okay. See the calculation. Total cost is equal to direct cost plus indirect cost. Direct cost is nothing but normal cost. Okay, how much? As per the information given in the problem, 6,000 no. Plus indirect cost 100 rupees per day. How many days it will take to complete the project? 26 days. So 100 into 26 days, 2,600. Total 8,600. Okay. So far we have calculated crash limit, slope, critical path, normal project duration and its total cost. Okay. Based on these information, we will start the crashing procedure. Okay. See the crashing the network table, crashing the network, and here we have entered various paths including critical path and duration. For the first critical path, 6 plus 5 plus 10 plus 5, total duration 26 days. In the same way, we have entered duration for each and every path. Okay. And the total cost. So which one is critical path? Highest duration. Longest path is the critical path. So 26 days. For that, what will be the normal cost, total cost? So total normal cost plus indirect cost. For indirect cost, 26 days, no. 26 into 100 rupees each. Total 2600. Direct cost plus indirect cost is equal to total cost 8,600. This is the normal cost, okay, for the normal project completion time. Now we are going to crash the network in order to reduce the number of, that is optimum duration along with the optimum cost. Okay, so our intention is to reduce the duration, at the same time we have to reduce the cost. Okay, the next step is we need to create one table called selection of activity for crashing. That is which activity we need to crash in order to minimize the total cost. Okay, see, this is the table for selection of activity for crashing. Okay, for that, just take the critical path. According to our problem, we have only one critical path. Okay, you can proceed with that. Suppose if you have more than one critical path, what to do? For that, already I have uploaded one video, that is crashing with two critical paths. The link is available in the description box. Okay, see here, our critical path is 1 to 2, 2 to 3, 3 to 5 and 5 to 6. So enter the activity. Okay, 1 to 2, 2 to 3, 3 to 5 and 5 to 6. And then just enter the crash limit for these activities. Okay, already we have calculated crash limit for all the activities, as well as we have calculated cost slope for all the activities. Now we are going to enter only crash limit and slope for critical paths. Okay, for the first one, 1 to 2. 1 to 2, crash limit is 2. Next, 2 to 3, 1. Then 3 to 5, 2. Then 5 to 6, 1. So enter crash limit for these activities as well as slope. Already we have calculated, no. See, 1 to 2, 75 rupees. 2 to 3, 50 rupees. 3 to 5, 25 rupees. 5 to 6, 110. Okay, just enter slope for these activities. Okay, now you have to select the least one. So out of these slope, we need to select least cost slope. Okay, which one is least? 25 is the least one. Just select this particular activity. So 25 is the slope cost for this particular activity. Okay, so the crash limit is maximum you can crash 2 days. So you can crash one by one. So first I am going to select this particular activity and I am going to crash 1 day. Okay, what will be the result? There will be no change in this. Here also no change, and this will become 1 and this is same. Okay, so I am going to crash this particular activity by 1. See the crashing the network table. Okay, this is the critical path and this is the normal duration. Okay, so what is the normal duration? Completion time 26 days, no, and this is the total cost at the normal completion period. Okay, now according to the previous step, we decided to crash 1 day. Which activity? 3 to 5. In this particular activity, we are going to reduce 1 day. What is the normal duration? 10 days, no. Now we are going to reduce from 10 days to 9 days. 1 day we are going to reduce. Then the total duration will be 25 days. Okay. and there will be no change in the other parts because 3 5 is not there in the other options. So it is not going to be changed. The same thing you can record, only it is going to affect in the critical path, that to 1 day. See, here we have entered the critical paths and duration as well as the total completion time. Okay, so here I have changed from 10 days to 9 days. Okay, so what is the total completion time? 25 days. And it will have a change in the cost. Now enter the cost. For this particular calculation, just take the previous total cost, that is 8,600. Okay, we have reduced from 26 to 25 now, 1 day. So it will lead to decrease indirect cost. According to this problem, indirect cost how much? 100 rupees, no. So that 100 rupees you have to subtract because it reduced from 26 to 25. So minus 100. Okay, so because of crashing, you have to incur extra expense. So how much extra expense? Just see the cost slope. See this table, that is selection of activity for crashing. Okay, for this particular activity, that is 3 to 5, what is the cost? That is the slope cost, 25 rupees. Okay, so you have to incur additional cost. This is the additional cost. Just add this amount in the calculation. What is the total cost? Previous cost minus 1 day reduced, so minus 100 plus extra amount. How much extra cost incurred? 25 rupees. So add. The total cost will be 8,525. It reduced from 8,600 to 8,525. So you have to do the same procedure until we reach the optimum cost and optimum duration. Okay. Again, you have to go for the selection of activity for crashing. See the selection of activity for crashing table. Again, you have to select the least cost slope. So which one is least value? 25. That is this particular activity, 3 to 5. So out of 2 crash limit, already we have crashed 1 day. Still we have 1 more day. Okay. So I am going to crash this particular activity by 1 day. Then it will become 0. Okay. All other crash limit is going to be remain same. Okay. So I am going to crash the same activity 3 to 5. See the crashing the network table. According to the previous calculation, we have found that we can reduce 1 day in this particular activity, that is 3 to 5, but the same is not applicable for other parts. Okay, so it is going to be remain same, but in this particular critical path, what is the duration? 9 days. If you reduce 1 day, what will be the result? 8 days. Okay, so 25 will become 24. Other two parts duration remain same. And what is the cost? Same formula. So previous calculation 8,525 minus 1 day reduced, no. So minus 100 rupees plus cost slope. How much? 25 rupees, no. So just add this extra expense. And what is the total? 8,450. It reduced from 8,525 to 8,450. Okay. Still we can proceed further until we reach the optimum cost. See the selection of activity for crashing table. Here the least cost is 25 rupees, but already we have crashed 2 days. Now it is 0. Okay. So eliminate this. What is the next least cost? 50 rupees. Now I am going to select this particular activity. So what is the crash limit for this particular activity? 1 day. So I am going to select this particular activity to crash 1 day. Okay. 0 and this is same. This is 0 and this is same. See the crashing the network table. According to the previous calculation, we have found that we can reduce activity 2, 3. Okay. So activity 2, 3. What is the duration? 5 days. Okay. If we reduce 1 day, it will become 4 days. Okay. What is the total duration? 23. Okay. So this is the critical path and there is no activity 2, 3 for other parts. Okay. So there will be no change in the other two parts. It is going to be remain same. Suppose if the same activity is there in the other path means even that particular path we have to reduce 1 day in that particular duration. Okay. It will have an impact on the other parts also. But in this problem, 2, 3 activities not there in the other parts. Okay, you can enter as it is. There will be no change in the duration. Okay, now find out the total cost. Okay, total cost, same formula. Previous total cost minus 1 day reduced, So minus 100 plus what is the slope cost? Extra charges 50 rupees. So total 8,400. Again it reduced. Okay. Still you can proceed further until you reach optimum cost. See the table of selection of activity for crashing. Again find out the least cost. Okay. So for 50 nil, no crash limit is there. So strike out this. And what is the next least cost? 75 rupees. So I'm going to select this particular activity. That is activity 1, 2. Okay, here we have 2 days. That is crash limit is 2 days. No. So we can reduce by 1 day. Then it will become remaining 1 day. Here 0, 0. The last one also 1 day is there. Okay, see the table. See the table of crashing the network. Okay, according to the previous calculation, we have found that activity 1, 2 can be crashed by 1 day. So what is the normal duration? 6. Now we are going to reduce 1 day. It will become 5 days. Okay, but the same activity even applicable in the other two parts also. Okay, 1, 2 is there. Here also 1, 2 is there. Okay, activity 1, 2 duration will be reduced from 6 to 5. Okay, so here also 6 to 5 and here also 6 to 5. Okay, and what is the total duration for the first one? 23. No, it will become 22. 1 day we have reduced. No, so it will become 22 and the other two parts are 16 and 16. Again we need to check the longest path. Which is the longest path? 22. Okay, so this is the critical path. Okay, now just enter the total cost as it is. The previous total minus 1 day reduced. No, so minus 100 plus the extra cost 75 rupees. So total 8,375. Okay, it reduced from 400 to 375. Still you can proceed further until you reach the optimum cost. See, selection of activity for crashing table. Still this is the least value 75 and we have one crash limit. Okay, so I'm going to crash 1 day for this particular same activity 1 to 2. According to the previous calculation, we have found that we can reduce 1 day, okay, in the same activity 1, 2. Okay, so now it is 5 days no normal duration. You can reduce 1 day, it will become 4 days. The same activity 1, 2 is applicable even for the other parts. So it will have an impact. 5 will become 4. Here also 5 will become 4. What is the total duration? 22 will become 21. 16 will become 15 and 15. Again we have to check the critical path. Okay, still the first path is the longest path, 21 days. No, so this is the critical path. Okay, now see the total cost. Same thing, previous total minus 1 day reduced. No, so minus 100 plus extra cost 75 rupees. Total 8,350. So 25 rupees reduced. Still you can proceed further. See the selection of activity for crashing table. Okay, so this is over. No, strike out. And the last option is only one option is there. That is 110 rupees. So I'm going to select this one. And this particular cost is related to this particular activity. Activity 5, 6. So how many days are there crash limit? 1 day. So then it will become 0. So there will be no further crashing limit. Okay. See the crashing the network table. So according to the previous calculation, we have found that we can reduce 1 day in this particular activity 5 to 6. But the same activity is there in the second path also. 5 to 6 is there. No. So we are going to reduce 1 day. Okay. Then it will become 5 will become 4 days. So total duration is from 21 to 20. For the second path from 15 to 14 days and there is no change in the third path. Okay, that's all. Now find out the total cost as it is. Previous total minus 1 day reduced, from 21 to 20. Still this is the critical path. Okay, so minus 100 plus the extra cost, that is the slope cost. How much? 110 rupees. So what is the total? 8,360. See here, the total cost start increasing. The previous calculation is 350. Now it will become 360. So now we can stop the procedure. We got the optimum cost and optimum project completion time. Say, since the total cost of this iteration is more than the previous iteration, so treat this particular solution is the best solution. Okay. See the critical path is 1 to 2, 2 to 3, 3 to 5 and 5 to 6 and corresponding optimum project completion time is 21 days and optimum total cost is 8,350. Okay. In the next video, we are going to see crashing the network with single, double, and triple critical parts in the single problem. Okay. The links are available in the description box. Hope you like this video. Please hit the like and comment, subscribe and share with your friends. Thank you.